I'm Dan Allford with Offshore Robotics.
I'm John Martin.
James Lippold.
In 2022, we detected a need on drill ships for automation with robots. And to address it, we built the system you see behind us right here.
What we have here is a robotic riser system. It has two robots that are making and breaking the connections of a riser. And the riser is what connects the drill ship to the sea floor, and all the drilling operations happen inside of it. So James here, talk us a little bit about the tools that we're using and that kind of stuff that are on the robots to make this happen.
Yeah, the tool that's on the end of the robot is a multifunction tool that allows the robot to manipulate and move the bolts to their desired locations. Also utilizes a high spin motor to spin down the bolts quickly. And then after that, it uses a high torque cylinder to torque down the bolts at 18,000 foot-pounds.
Superficially, this is just an assembly job, but the problem arises that we have to find the bolts, find the locations, and all this is happening on a drill ship with everything moving out in the ocean. This happens twice when you're drilling an oil well, once when you're spudding in, and then once the well is completed. So we have how many of these systems running now?
We have 3 current systems operating in the Gulf of Mexico. We have done this. The first deployment was in September of 2022. And so this year we're shipping our first system to Brazil. And then we have 2 more systems going into the Gulf of Mexico this in 2026. So that will double our exposure that's currently out there for 6 complete systems.
This will have a good reception on drill ships. People seem to appreciate this bit of automation because this was one of the most dangerous jobs on the boat, right?
Right, it's one of the only times we've been doing automation. I've been putting systems in for over 20 years, and it's the only installation that somebody has came to me and said they want this to work, to take their job away.
Very dangerous job, very hard job. These bolts weigh 50 pounds, and anything you're torquing to 18,000 foot-pounds, just the forces are just extreme.
Right, and you do it for 12 hours a day, and you're lugging around a 300-pound torque wrench. It's very abusive on the people doing it.
So we're the management team for this new company, and I was kind of worried that this might be a one-trick pony, one-job company, but you got some good news, right?
Right, we got other systems we're working on for offshore drilling industry. We have a Sacrum system that is manipulating the sacks for the batching of the drilling muds and cements they use various products. And then another system that we have way in the background here is a continuous circulation robot to automate the connection of the mud line, so they can continue flowing mud as they go from stand to stand with the top drive.
And so these robots here are working in an environment where there are no hydrocarbons. That simplified matters, didn't it?
But the idea was take the industrial robots and that have been operating in manufacturing facilities for years, and take that known product and take it to an offshore industry. Make it a little bit more robust, put some covers on it, use the foundry grade packages that they offer, but change the connectors out. Go to ATEX protection, put these different things on them that the environment requires.
So it's a little more complicated than just moving a robot out of a factory and over here. Just the connector cost alone is a substantial portion of the new robots, isn't it?
Yes, the robots themselves are pretty economical, but once you add the robustness to them, it does increase the complexity and cost.
What I like is we're taking the technology we developed for standard industry and then reapplying it. You can see in the background we're running laser stripe tracking. You're using that to find parts. And we're running soft float. This is a lot of traditional robotic technology that's been reapplied to the field.
Correct. Yes, there's a lot of sensors that are added to as well. Hydraulics, as James can tell you on the hydraulic system of the robots, it's not normal, but it's something that we added to it for this type of robustness industry.
Yeah, to utilize hydraulics in our application, we need to make sure we have good control over flow and pressure, because pressure really matters when it comes to a final torque, and then also precision flow to make sure the spin rates are in sync with the robot movement.
So originally we had these tool changers in place because you were running 2 tools.
That's correct. Yeah, the very first revision was 2 different tools. One was for the high-speed function and the bolt manipulation, and then the second tool was the 18,000 foot-pound torquing unit. We worked through some component issues, and then also decided to increase cycle time by taking both of those functions, those tools, and putting them all into one.
By going to a single tool, we cut some cycle time. And on a drill ship, it's between, we hear numbers between $1 and $5 million a day to operate a drill ship. So it's between $1 and $4,000 a minute. So every second you guys save, it adds up quickly. So I think that's remarkable with the single tool, what you guys have done.
I think it's important to note the acceptance of robots and automation in this type of industry, because it's ripe for automation. They're doing everything manually. It's been done that way for years. They look to become more efficient, and this is the way they're going to do it, is with robots and automation.
I think it's a great application. And the whole concept of taking robots out of a factory and moving them directly to where the problem is, there's not a lot of companies doing it, but it's working out very well for us.
Right. Yes. Doubling our deployment in 1 year. So we're excited for next year.
And that's just with the first application.
Right.
So you're developing robots that'll work around hydrocarbons now, aren't you?
Yes. So we're going through a process of internally purging the robots' electronics and enclosures, and making it into an ATEX rated device.
Because currently the only explosion-proof robots you can get off the shelf are paint bots.
Correct. They're low payload, usually 15, 30 kilograms, where we're dealing with 230, 280 kilograms. So in order to do that, we have to take the known applications of purging and removing the gases that may be flammable inside of enclosures to the robot.
So now we can have heavy-duty robots working in dangerous environments.
Correct. This opens up for drill floor robots, for robots that are operating while they're drilling, while they're connected to the well, instead of like the riser operation here that happens when they're disconnected.
Pretty exciting. So by us branching out into these radical new fields, it helps us to keep our company busy. It's been a lot of fun. I applaud you guys' efforts. You've done a great job. We've actually created a couple of new patents, right?
Yes, we have the riser robot patent and the drill floor patent going through the process right now, as well as our Sacrum. There's also patent applications that are going through on a continuous circulation project.
I've been in robots for 40 years, and this is just a radical new application by moving them out of the factory. So you're having to deal with sunlight, water spray, just very hostile environment.
And it's we've been, like I said, about 2.5 years of robots in the field, and very few robot failures. They've been very robust and honestly surprising on our part. We figured that we have some water intrusion. We do have to, like I say, change the connectors, but very robust devices.
Well, that was the point of the exercise. Robots are a mature industry. The mean time between failure is now measured in years. And this is a hostile environment, a great testing place for robots, and they're doing well. So what's in the future, guys? What's next for Offshore Robotics?
Like I said, there's everybody wants a robot to handle tubulars on the drill floor. So as James said, you go up to 2,000 kilograms. You can manipulate a lot of devices. Right now they're doing by hand, and that puts people in the red zone, and robots don't mind the red zone. They love it.
And what is the red zone?
That's the most dangerous area on the drilling rig. That's an area between the two well centers that they try to keep as clear as possible, because that's where heavy stuff is being lifted and may fall.
But without this system, you got humans in that zone.
Correct. Yes, all over that zone.
Impressive stuff, guys. Keep up the good work. I'm looking forward to seeing where Offshore Robotics is in a few years.
Thank you.